Today we are going to work on balancing chemical equations. This is important because of the law of conservation of matter, the law of conservation of mass. This law says that anything we put into a chemical reaction must come out. We went over the steps already. First, we're going to count how many atoms of each element are on each side of the equation, and that will allow us to figure out which element is not balanced. So that's where I'm going to start. My elements present are lithium, nitrogen. Oh, that's it. So first, I'm going to look at my left side, which are my products, my reactants. I'd like to draw a nice squiggly line to help me visualize this. On the left side of the reaction, I have 1 atom of lithium, and I have 2 atoms of nitrogen. On the other side of the reaction, I have 3 atoms of lithium and 1 atom of nitrogen. Both of these are unbalanced, so we can choose to start really wherever we would like. I'm going to make the decision to start with nitrogen. So if I start with nitrogen, I'm going to have to first add a 2 right here because I need more nitrogen over on the right side of the equation. By putting a 2 there, I have now changed the number of lithiums I have. Remember, I have to multiply that. So 2 times 3 means that I have 6 lithiums. And I also, in each of those groups, have 1 nitrogen. So 2 times 1 gives me 2 nitrogens. I have now balanced my nitrogens. So I have 2 nitrogens here, 2 nitrogens here. I'm good to go. Next, I'm going to look at my lithiums. If I go back over on the left side of the equation, I need to have over here a total of 6 lithiums, over here, a total of 6 lithiums in order to balance this out. So to do so, I'm going to put a 6 in front of lithium. I'm putting the 6 in front of lithium. I have now changed lithium to 6. I didn't mess with nitrogen at all. So now I just have to go ahead and check that everything balances. 6 and 6 balances. 2 and 2 balances. Lastly, I'm going to do step 5 is I do have to look at my coefficients. My coefficients are 6 to 1 to 2. Remember, there is an invisible 1 there. Is this a lowest whole number ratio? You betcha. Next reaction I'm going to take a look at is going to end up with some larger coefficients. That's okay. There's a little bit of trial and error involved sometimes. I've got aluminum, I've got iron, and I've got oxygen. So I'm going to go ahead and count. I've got 1 aluminum on the left, 3 irons, 4 oxygens. On the right-hand side, I have 2, 1, and 3. And again, I like to do my little red squiggly line. Visually helps me out a lot. Now, as I'm counting these and taking a look at them, everything is unbalanced, so I can almost start anywhere. I have a little pointer for you. This particular reaction is a single replacement reaction. What's nice about free elements is they're very easy to balance out when they're all by themselves, because any coefficient that we put there will only change that element. So typically I say starting with oxygen is not always a good idea. But in this case, I am going to start with oxygen because oxygen is the element that is in both compounds. Now, here's the good news. If you didn't follow what I said, you can trial and error your way through any of these problems. That's the nice thing about balancing equations. So the first thing I'm going to do is worry about balancing oxygen. Now, I would like you to notice something else about oxygen. I have 4 oxygens here and 3 oxygens here. The total number of oxygens that I have on my reactant side has to end up being a multiple of 4. Total number of oxygens I'm going to have over here will be a multiple of 3. You may have talked about least common multiples in math. Hopefully you did. The least common multiple of 4 and 3 is 12. Spoiler alert, we're likely to end up with 12 electrons, or maybe 24 or 36, but most likely just 12. So in order to make this pretty easy, I'm going to say, hey, what do I have to do to get 12 oxygens on each side of this equation? Because I have a 4 right here. If I put a 3 in this blank, it changes my irons. So remember, I'm doing 3 times that little 3. Changes my irons to 9. 3 times that little 4 will give me 12 oxygens. I'm going to clean this up a little bit. Next, I'm going to bop over to the other side. Now, on my other side, if I want to end up with 12 oxygens, if By putting a 4 right here, my 4 will be multiplied by that 3 for my oxygen, which gives me 12, and the 2 by my aluminum to give me 6 aluminums. I've now balanced my oxygens. My irons and my aluminums are all screwed up, but guess what? They're a pretty easy fix. I have 6 aluminums over here. In order to fix that on the other side, all I have to do is put a 6 here. Boom, balanced. If I bop back over to the other side, I ended up with 9 irons right here. I want to have 9 irons on my product side. So all I have to do is plop a 9 right here. Boom, balanced. 6 and 6, 9 and 9, 12 and 12. Let's look at my ratio. 6 to 3 to 4 to 9. Can't reduce that. I am done. Next reaction is a combustion. I have a huge piece of advice for you on a combustion reaction. Make sure that you start with carbon. One reason is oxygen is present in multiple terms. If you put a coefficient in the wrong term, it could screw things up a lot and make a lot of problems for you. So since oxygen is present in multiple terms, I usually recommend staying away from that to start with. You usually end up with large amounts of hydrogen as well, so that's not a great place to start either. So I'm going to go ahead and count. Got carbon, hydrogen, and oxygen. I have 8 carbons, 16 hydrogens, 2 oxygens. On the other side, I have 1, 2, and 0. I don't know why I said 0. Sorry. 3. Now, some of you might be like, why is that 3? We have 1 here and 2 here. So on my total reactant side, or I'm sorry, on my total product side overall, I have a total of 3. So as I mentioned, you should probably start with carbon. Now this may look a little crazy because we have 8 carbons on the left-hand side of this reaction. So we have to jump right in by putting an 8 here. That's a big number, but that's all right. So now we have 8 carbons represented. 8 times 2 gives me 16 oxygens here, and I still have 1 here. So that's going to change my oxygens to 17. Now, oxygens will be reasonably easy to fix on the other side of the equation because oxygen is by itself. Keep in mind, though, oxygen's got a 2. We're probably going to end up with an even number of oxygens. That might help us down the line. So now that I've balanced out my carbons, the next thing I'm actually going to tackle is I'm going to go ahead and I'm going to tackle my hydrogens. On the left side of my equation, I have 16 hydrogens. On the right side right now, I have 2. Pretty easy fix to turn that into 16 hydrogens. By putting an 8 here, I now have 16 hydrogens. I have also affected my oxygens. I still have 16 in this term. In this term, I have 8 times 1, or 8 oxygens. 8 plus 16 is 24 oxygens. Combustion does use up a lot of oxygen. So now that I have my 24 oxygens here, I've got to go back over to the left-hand side because of this little tiny 2 right here. By putting a 12 in this blank, 12 times 2 gives me my 24 oxygens. It's my 8s, my 16s, my 24s. I'm good. I have a ratio of 1 to 12 to 8 to 8. I'm balanced. I'm in a lowest whole number ratio. Things are looking good. At this point, I have 2 I would like you to try on your own. So go ahead, pause the video, and try this out. When you hit play, I will put the answer up as well as walk you through the problem. So the solution for the first reaction that you have to try on your own, we've got calcium, sulfur, oxygen, aluminum, and fluoride. I'm going to go ahead and do my counts. I've got 1 calcium, 1 sulfur, 4 oxygens, 1 aluminum, 3 fluorides. I've got 1, 3, 12. Remember, that 3 distributes to each of those. Aluminum is 2, and fluorine is 2. First thing I'm going to do, because this is a double replacement reaction, I can pretty much start anywhere. It doesn't really make a huge difference. I've made the decision in this reaction to start with fluorine, and I'm going to tell you why. This fluorine has a little tiny 2. This fluorine is a little tiny 3. Sulfate is a polyatomic ion, which can make things a little bit trickier, just a little bit more to deal with. Because I have a 2 on my product side, I have to have a multiple of 2 fluorines, or an even number. On my left-hand side, I have to have a multiple of 3 fluorines. This gives me a little clue that I might end up with 6 fluorines. If you didn't like what I said there and you want to just do it trial by error, that's fine too. I know I'm going to need more fluorines because I only have 2 over here. So by putting a number in front of my fluorine over here, if I wanted to start with the number 2, I could absolutely do so. What that's going to do for me is it's going to give me 4 fluorines here, 2 calciums. Now the problem is I can't balance fluorine with a 4 here and a 3 here. So then I would just bop over to the other side where I'd be putting a 2 right here. By putting a 2 there, I've changed aluminum to 2. I've changed fluorine to 6. Now I gotta go back over here. That's where my trial and error comes in, and I'm gonna end up with a 3 right here. If you used the idea of the least common multiple, you could do that without the trial by error. So now I've got my fluorine fixed, my aluminum's looking pretty good. I still have to fix my calciums and my sulfate. Now I can see very clearly I have 3 calciums right here, so just to fix that I can plop a 3 right there. That then fixes my calcium. How are my S's and my O's looking? 3 times 1 gives me 3 sulfurs. 3 times 4, 12 oxygens. I didn't put anything here, so I don't have to change that up. 3 and 3, 3 and 3, 12, 2, 6. I've got a ratio of 3 to 2 to 1 to 3. Good to go. And the very last one I'd like you to try, if you have not done so already, take a moment to do that now. Although there are only 3 elements here, it is a little bit tricky. You do end up with some decently high coefficients. So we're going to start by counting them out. 1, 3, 2, 2, 2, 1. What I would suggest starting with here, the hydrogen might be the easier thing to start with. This is a single replacement, and so hydrogen is going to be in both of your compounds. Nice thing about starting with hydrogen, you got a 3 here, you got a 2 here, which tells you how many hydrogens do you think you're going to end up with? Probably 6. So in order to get 6, I'll put a 2 here. I'll change that to 6. My nitrogen will change to 2. I'm going to jump over to the other side, fix my hydrogen over here by putting 3. It's going to give me 6 here, and it's going to give me 3 here. I fixed my hydrogen situation, I fixed my nitrogen situation. Now, oxygen might be giving you a bit of a headache, and this is actually a great example of trial and error. Because if you started with oxygen, you'd see that you're going to end up in a situation where you have to have an even number of oxygens. So I'm going to need to change what I put in front of H2O. That is not an even number. In order to end up with an even number of oxygens, I have to go up from what I had there. I have to go up from my 3. So maybe I'll try 4, which is going to change hydrogen to 8, and it's going to change oxygen to 4. That creates a problem for my hydrogen over here. This is a pretty tricky question. We can't end up with 8 hydrogens there. So I'm definitely not going to end up with a 2 here, but I'm not going to be able to get my multiple of 8. So to make this guy go up, I'm going to plop a higher number here. If I try a 3 here, that's going to give me a 9 for hydrogen. That's just gross. I don't want that. So I'm going to actually go up to my next even number, which is going to be 4. So I'm going to have 4 nitrogens, 12 hydrogens. I still haven't messed with oxygen too much. When I bop back over here, what this tells me, if I want to end up with 12 hydrogens on this side, I need a 6. So that changes my hydrogen to 12, my oxygen to 6, my nitrogen, and to balance that out, all I got to do is put a 2 there. That becomes 4. All I gotta do to fix my oxygen is put a 3 here. A little bit more of a complicated problem, but through trial and error and using your subscripts, you can figure it out. We've got a 1 to 3 to 2 to 6 ratio. You can actually occasionally be asked to sum these. If you summed these, you would simply do 4 plus 3 plus 2 plus 6 equals